Hi everyone, this is Mohan Raghavan, and today we are going to see the normal equation practical. In previous couple of videos, we have seen what is normal equation, what is slope, and what is the different kind of differentiation, and what is gradient descent. So those so many things we have seen. But however, from this videos onwards, we will be seeing the practical course snippet for the different kind of gradient descent and normal equation. When we start finding the optimal value for theta, initially we started with normal equation. So in this video, we are going to see how to see the normal equation, how to find out the optimal theta value by using the normal equation. And we will see how effectively it finds the theta value. The first code snippet, import numpy and import matplotlib, and after that inline statement just to display the graphs in the inline. And after that, we are just going to find the x and y values randomly. First line, x is equal to 4 into np dot random rand 101. So we will go step by step. In numpy, we have the function random dot rand. It will give the random values between the 0 and 1 in the form of uniformly distributed values, right? So then we will be giving the rows and columns here. That means that we have 100 rows with one column. So you will be having the 100 values ranging between 0 to 1, and that will be given as a input for this statement. But however, having values only between 0 and 1 may not be enough. So for that, we are just multiplying with 4 so that you will be having maximum 4 and minimum 0. So that means that you will have 100 values ranging between the 0 and 4. So that will be coming in the x. Next statement, we are framing the equation. So let's consider you are creating the line equation itself. The line equation will go like y is equal to mx plus c, where m is equal to slope and c will be your intercept in the y axis, right? So now here we are considering y is equal to mx plus c. So here c is 4 or theta 0 you can consider, and theta 1 or m value will be 3. So slope will be 3. Then after we are multiplying with x. So when you consider this one, it will be the line equation. But if you directly use this equation, you will get the straight line. But however, we are just simulating the input data set. For that, we need to have a little noise in the data. So for that, we are just adding 3x plus some random value from the 100 rows and one column. So that random value will be taking from the numpy module np.random.rand_n. If you see here, it will be random n, here it will be rand. So that means that random n stands for random from the normalized data. So the data will be normalized, so normally distributed data. So when you execute these two lines, so you will come from the starting, execute, execute. So now we have the values. Now we will just plot the data directly. So you will be having the like almost like a linear regression, but however the noise will be there, so you will not have the proper way. For example, if you remove that directly the random value, if you don't add that random value, so you will be forming like a straight line. So just execute and execute. So you can see the straight line itself, but we are adding that random value so that you will be having like a actual data. So now you have the actual data. So now we have the y value and x value, and we have decided the slope and let's say the y-intercept. So slope will be 3 and intercept will be 4. So for this data set, we are going to predict the theta value. Now we know that we have decided theta value as 4 and 3 respectively for theta 0 and theta 1. Now from the previous video, we know that the normal equation will be like x transpose x inverse. So the product of x transpose into x dot product, then the result will be taken as a inverse of matrix, then after x transpose into y. So now we have x and y both in our hand. And however, we will see one more concept here. Let's say your data set will be having now only one feature. So x1 x2 x3 values, the value will be x1 x2 x3, and the actual value will be y1 y2 y3 respectively till y100, right? The same way for x100. But however, you need to have the one value as the first column. Why? Because we will be having the theta 0. Theta 0 will not have any x coordinate, or let's say x future to be multiplied. So for that reason, we need to have the one value as the first column, so that when you multiply theta with 1, it will come as a theta. which is our y-intercept. So for that reason, we will be always adding the, in X matrix, we will be always adding the 1 value in the first column. How many rows you have, those many rows you will add with all having the 1 as a value. So now here we are going to create the NPC ones, 100 comma ones, and we are adding, in this line we are adding the column NP ones. It will give the 100 rows with all having the 1. And after that we are adding the X value. So at last you will be having the X value, but preceding with the 1 column all having the 1. So that will be your X underscore B. So here the naming convention is X underscore with bias value. So the bias value will be 1. Next one, theta paste. So now we will apply the same formula. To apply the transpose and inverse kind of operations in NumPy, we have the module linear algebra, shortcut is linalg. So that one, after that we are making the inverse of operation. So inverse of operation, inverse of X transpose, so XB, sorry, X underscore B dot transpose. Then after dot product of XB. So that means that X underscore B, the X value only. So this one will give entire this first part, and second one dot product of X transpose B dot D. Again we are taking the transpose of X underscore B, then dot product of Y. So the entire equation will be converted into the code snippet here. So at last you will be getting the theta value. The theta value in our case will be like, since we have 2 columns in the X, so we will be having the 2 theta values. So after executing this one, you will be getting the theta value. See, now you can see clearly theta 0 is 4 in actually we planned, and here it is giving 4.1, almost near. And after that theta 1 we have decided as 3. Here it's giving 2.9, very close to the 3. So now our theta values, whichever got predicted by our normal equation, almost equal to the actual theta values in the data. So then after we are just going to check for our actual equation. We planned m is equal to 3 and c is equal to 4. So for that, if you substitute x value 0, then you will get y value as 4, and if you substitute 2 as a value, and you will get y value as 10. So this is the actual calculation, but however, based on our new theta value, we are going to calculate our x and y values for respectively for 0, 1, 2. The new array we are going to create. So as usual, it's like this way. So you will be creating the x1 and x2. So you are creating x1 and x2. It's just like a 0 and 2, whatever the values we substituted here. So 0 and 2 will come as a 1 column with 2 rows. First row will be having 0 and second row will be having 2 value. As we discussed earlier, we need to add the 1 as the first column. So for that we are adding np.c underscore adding column as a first. Then the first value will be np1s 2 comma 1. That means that 2 rows and 1 column, and that will be having all as 1. So that means 1 1, it will be the 1 column, and it will be having 2 rows. And x new, whatever we will put 0 1 2. So now if you see this x underscore new underscore b, that will be having 1 and 1 as the first column for the theta 0 value, and second one will be our actual x value 0 1 2. And you can see the matrix also here. X shape will be like 2 into 2. Now theta best shape, so that also coming 2 rows and 1 column. So why it is 2 rows and 1 column, let's consider. Here it will be the 2 rows and 1 column, theta 0 and theta 1. It will be same like our first matrix. So here if you can see, the row into column will be here, and this row into column will be here. So the column of first matrix and the row of second matrix will be equal. The result will be the row of first matrix and column of second matrix. Now we are just giving the, let's say, predicted value we are going to find x underscore new b. So that will be having 2 into 2 and dot product of theta paste. Here if you see, the theta will be calculated with first one, and then theta 1 will be calculated as a x1. So both will be added and you will be getting one value, that is the predicted y value. The same way for theta 0 will be multiplied with 1, so that intercept will be coming directly out, and theta 1 will be calculated or multiplied with the x2. So those value and the first intercept value will be added, and that will be the second predicted value. So those things will be done here, and if you execute this line, so you will be getting the value 4.1 and 9.9. The actual value what we just executed with directly with the line equation will be 4 and 10 predicted values respectively. Here we are getting 4.1 and 9.9. So almost our prediction is equal to the our actual values. So that means that our theta values are working more or less correctly. So next one, just with having these 2 points, we are just going to plot the line. Here, if you plot the line directly, it will be the dot only. But if you mention that, say, the hyphen symbol, it will be drawing as a line. So let's consider this one, x new and y predicted. So that means that our input value is 0 and 2. And after that, we will be having the predicted value, y predicted value will be 4.1 and 9.9. With these 2 points, we are going to draw the line. So the line will be hyphen symbol and the G represents the green color. So now we are just displaying this one. So just execute and see. So this will be our data points. And after that, we are getting the straight line. So our linear regression line will be like this in green color. So this is all about the normal equation. So it's very simple. First of all, we understood how to frame the data by using the rand and random n. So random n stands for random values, but it is normally distributed. So normally distributed in the sense you will be having the mean as a 0 and the standard deviation will be 1 always. Then after, without random value, it will be like a straight line, but just to have a noise, so we have added the random value to the line equation and we noted down what is the theta 0 and theta 1 respectively. Then by applying the normal equation formula, x transpose into x, inverse of that value, dot product of x transpose y. So that will be giving the actual theta values. And we have seen why do we need to add 1 as the first column to get the theta 0 as it is, because y intercept will not have any x multiplication or future multiplication. So after that, by applying the formula, we got the theta values, the best theta values. Then we compared with the normal equation with the same y is equal to mx plus c, having m is equal to 3 and c is equal to 4. We found two predicted values, and the same values we have given in the predicted, let's say the found theta values, and we found the values are like almost like equal to the same like our actual values. Then we have drawn the line and we are seeing how it looks like from the normal distributed data along with our linear regression line. So this is all about the normal equation. So thanks for watching and have a great day.